In this video, we are going to perform hyperparameter tuning using one more technique, which is called as randomized search CV. In our previous video, we have already done it with grid search CV. Now in grid search CV, what this algorithm or whatever algorithm we are basically using and hyperparameter tuning it usually takes all the combination of all the parameters that we are using over here, right? So usually when we take all the combination, it will obviously take more time. So in order to overcome this, we basically use randomized search CV. Now in randomized search CV, what it will do is that it will make sure that it will pick up random attributes or random parameters, and then it will try to create some, it will try to find out what parameter will be suitable for a specific problem statement. Now everything will be almost same. All I am going to do is that you can see how we can import randomized search CV by from importing SQL on model selection. Again, the parameters are almost same like grid search CV. Here you have estimator, parameter distribution, number of iteration, cross validation value, and scoring value, right? And then we can basically do this. So let's go ahead and let's quickly import first of all from sklearn.model selection. I'm going to import randomized search CV. And once I execute this, all I have to do is that write random CV and initialize to randomized search CV. And here again, if you press shift tab, you'll be able to find what all things are there. So first I will go and give my estimator. And before that, I will just initialize my model to logistic regression. So for that, I will just try to copy the same thing. And after doing this also, we will be able to see some difference. Okay, so estimator over here will be my model, and then I have something called as param distribution, and this param distribution will be assigned to the same parameters that we have created right over here. So this will be my params that will be given over here. And I will also be using some cross validation. CV is equal to 5. Scoring parameter I will again be using as scoring is equal to for accuracy. I'm going to use the accuracy parameter over here. And after this, is there any other parameter that I have left? I think this will be more than sufficient to initialize random CV. So let's go ahead. And in the next step, what I'm actually going to do, all we have to do is random CV.fit on my X train, comma Y train. So internally, this is also doing cross validation. And once I do the fit here, you'll be able to see some warnings. Okay, here it says that L1 ratio must be between 0 to 1 and all. So by default, L1 ratio is not given over there. So some warnings you'll be able to see over here, but at the end of the day, training will happen. Okay, now I will go and basically write random CV dot and press best score. So you can see from the best score, I'm actually getting, using randomized search CV, I'm getting 91.28%. And if I also write random CV dot best params, you'll be able to see what all parameters got selected. You can see solver, saga got selected, penalty L2 got selected, and C was 100, right? And if you probably see with respect to grid search CV, here what all parameters that got selected, solver, and penalty over here was L1, there got selected as L2, and C value is quite high, over here it was quite less, right? So any of the two techniques you can use, but at the end of the day, when I probably do dot predict on my X test data, right, I will be able to get ypred, and this ypred, I will again try to use all my parameters that are this parameters and try to see what is the accuracy that I'm actually getting, right, for my test data. So here it is. Here you can see I'm getting 91.6. It is almost same. And again, one advantage with randomized search CV is that this entire hyperparameter tuning, when you have large number of parameters, this will take less amount of time when compared to grid search CV. Okay, but at the end of the day, we should try each and everything, to get or see how the accuracy is basically fluctuating between models. So these were the two hyperparameter techniques that I have actually taught you in this series. And as we go ahead, we'll be also learning about the other hyperparameter tuning techniques. Now, the next topic that we are going to cover is something like how do we solve multi-class classification with the help of logistic regression. And for that, we are going to use one versus rest technique. So let's see how we can basically use it. I will basically see you on in the next video. I hope you're liking the sessions. Please make sure that you revise again in order to practice more and more. And yes, please try to change your data set and again, try to see to it. Okay. So I will see you all in the next video. Thank you.